Hello friends, in this video we're going to discuss about orthogonality of Legendre polynomial. So we're going to prove this property here. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you get the option to hype, then please do hype the video. Okay, and if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT 123. That's my Insta ID. You can follow me on Insta. So now let's start. So here is the property. So Pm of x into Pn of x here, integration from -1 to +1 of this is equal to 0 provided n is not equal to m. So we gonna prove this. So here you see what is Pn of x or Pm of x mean actually. So these are the two solutions actually of these two equations, Legendre's equation, differential equation of this form. These are the solution. Here you see we can say that Pn of x is the solution of this equation 1 minus x square second order derivative of y with respect to x minus twice x first order derivative of y with respect to x plus n into n plus 1 is equal to 0. Sorry, I forgot to put y here. Here it is y. Similarly, Pm of x, what does it mean? This is also solution of this equation, same equation. Instead of n, I am gonna write m. So here same kind of equation, differential equation. Just here we're gonna replace the m plus n, n into m plus 1 by m into m plus 1. That is the difference. So hope you have got it now. So here you see, let me take this is equation number 1 and let me take this is equation number 2. So what we're going to do here, multiplying 1 by z and multiplying 2 by y. What we're going to do, just give me 1 second, let me change the variable here. Instead of y, let me write z. Okay, okay. So these two are same equations, but I have used different variables, right? As I have written here two different Legendre polynomials. So let me use z in the equation number 2 as variable instead of y. Okay, so now what we are going to do, we're going to multiply equation number 2 by y, equation number 2 by y, okay, and equation number 1 by z. Then we're going to subtract this. So hope you have understood. Now let me write the left hand side of equation number 2, then let me multiply y. Okay, so here is the left hand side of equation number 2 and let me multiply it by y. So let me take the left hand side only. So here we're going to multiply y, and in the second term as well, here we're going to multiply y. Then here also we're going to multiply y in the first term as well. Okay, so hope you have understood this. We have multiplied it by y. Then we need to subtract the left hand side of y, sorry, equation 1. What was the left hand side of equation number 1? Let me copy this part. Let me take the left hand side of 1. So here is the left hand side of equation number 1. Now you see what we have done here. We are multiplying z with equation number 1. Here you see as I have written. So we're going to put here z, and in the second term as well 2xz. Okay, and in the last term as well, as we have minus here, so sign will be changed. Here it is positive and the positive sign will be negative as we are subtracting, right? So here also we're gonna put z and equal to, on the right hand side, doesn't matter what you whatever you multiply with 0, that's gonna always give that's always gonna give you 0. So that's why on the right hand side we're gonna get 0. 0 minus 0 is always 0. So here we're gonna get 0, right? Hope you have understood this. So now let me simplify. How to simplify this? Here you see, let me check what are the terms common here. This 1 minus x square, 1 minus x square common. So let me write 1 minus x square. Okay, if we take it common, then within bracket we're gonna end up getting y into this, right, this term, then minus this term. Here you can see. Hope you have understood this. So now let me copy this term and let me write here. So this is what we have got after taking 1 minus x common, right? So hope you have understood this. Now let me close the bracket, minus. So now what we can do, we can take this term common, minus 2xy, sorry, not minus 2xy. Here we can take minus 2x common from these two terms, right? Then within bracket we're gonna end up getting this and this. So let me write here, minus 2x is taken common, then within bracket we have y into dz by dx, then minus z into dy by dx. So this is what we have got, right? So hope you have understood this. Now at the end, here we have yz, here also we have yz. Let me take those two also common, yz, and taking yz common, we end up getting n, it's supposed to be, okay, m into m plus 1 minus n into n plus 1. So here we have taken y into z common, equal to 0. This yz, right? Okay, so now what we can do here, just give me a second. So now you see here, we can write 1 minus x square integration y, second order derivative of z with respect to x, minus, we can write dz by, or we can write okay, this way. Just give me a second. Okay, let me write this one in this way. Here what we have, what we're gonna do, okay, let me write dy dx, dz dx, then plus sorry, okay, let me write here plus, here minus, then dz by dx, then dy by dx, minus z dy, sorry, second order derivative of y with respect to x. That's what we're gonna have. So now you see, if you cancel these two terms, again you're gonna get this, right? So why I have done this, I'm gonna explain later. Okay, so now similarly what we will do now in the next term, okay, let me keep the next term as it is. Okay, nothing gonna be changed here. So let me write this one as it is. Then what we have, just give me a second, let me rearrange these terms so that I can have enough space here. Okay, just give me a second. Okay, m into m plus 1, then okay, let me multiply this, m square plus m minus n square minus n, right? That's what we're gonna have. Now let me copy this last step and let me go to a new slide so that I can explain further. Okay, just give me a second. Okay, let me copy this and let me go to a new slide. So here is the last step. Here you see, let me explain now. So what is the reason behind introducing these two parts. Okay, so now let me explain. Here you see we can write this in this way: ddx of 1 minus x square into, within bracket we're going to get y dz by dx, then minus y z dy by dx. We can write this way. Let me explain how. Okay, let me explain how. Here you see. Okay, before I explain this, let me simplify this one as well. So from here, what we're going to do, here we're going to have m square minus n square, and m square minus n square plus m minus n, right? So here you see, so here we can write m plus n into m minus n. So m minus n can be taken common, right? So then we're gonna have m minus n is taken common here, then within bracket m plus n plus 1. Okay, these two are taken common here, you see. So this is what we have got. So let me write this way, right, equal to 0. Now let me explain this part. So if we apply that u into v rule here, then what we're going to do, so here you see first function 1 minus x square is the first function, derivative of the second function ddx of this part, let me write this one here, derivative of this part, then plus second function, that means this one, and derivative of the first part, that means ddx of 1 minus x square. So now you see, don't continue this, okay, just I'm trying to explain that why I have written this instead of this. So let me show you. Okay, so you don't need to write this step after this step. Okay, so we are going in reverse direction. I'm going from this step to that step. Okay, let me show that why I have written this instead of this part. Okay, so let me show you that. Okay, let me make a box here so that you don't mix it up. Okay, so here you see, then 1 minus x square, here you see, if you differentiate this again, here also you need to apply the u into v rule. So this is u and this is v again. Okay, so first what I have done here, so just differentiate this, considering this one u and this one v, you know ddx of u into v is nothing but u derivative of v plus v into derivative of u, right? We know this rule. So let me apply that one again here. Here you see, if you write here first function, that is y, and derivative of the second function, that's going to be second order derivative of z with respect to x, then plus, then second function, that is dz by dx, derivative of the first function which is y, okay, here, so dy by dx, right? Hope you have understood this. Then this part is done. Now we have this part, minus first function, that is z, and derivative of the second function, this part, okay, second order derivative of y with respect to x, then again it's supposed to be plus, but here we have minus, so it's going to be minus, so minus, then the second function, that is dy by dx, and derivative of first function, that is dz by dx, right? That's what we're going to have. Now you see here, okay, so you can cancel these two parts, right? Okay, now what we have here, plus this part, let me copy this, just give me a second. Let me copy this and let me put here. And you see, if you differentiate this, what you're gonna get? Minus twice x, right? So this plus will be minus. So now you see, so if you cancel these two terms, then what we have got here, we end up getting this result. So this is what we have got now, right? Okay, now here you see, this is nothing but this part. Let me show you this step, right? Again we have got this. That's why we have arranged these things like this way, so that we can obtain this form, right? Hope you have understood this. Let me cut this part. Okay, yeah, hope you have understood this, what I have done here. So now you see, so from here what we're going to do now, we're going to integrate it from -1 to +1. Okay, let me integrate it from +1 to -1, then you can write this way. Okay, derivative of this part. Okay, plus m minus n, m plus n plus 1 dx is equal to 0 in dx, right? So that's going to be 0 simply. So if you integrate it from -1 to +1, so m and these are constant, so we can write them outside the integral. So let me write this one here. So here you see, if you integrate, this differential coefficient will be removed. So here we're gonna have 1 minus x square, right? 1 minus x square. Then the second part here, okay, this is what we're gonna have. So we are integrating it from -1 to +1, upper limit and lower limit. So then here in the second term we're gonna get this, and if you integrate dx, then you're gonna get x. So again from -1 to +1 is equal to 0. So that's what we're gonna have. I think I have forgot to put the okay yz here. We should have yz, sorry, y into z. Okay, so here also we're gonna have yz. Let me write this one here, yz. Okay, so if there is yz, then we're gonna write this one here, integration -1 to +1 yz inside the integral. Okay, sorry, yz. So this is what we have, right? So now you see, so let me keep this one this way, yz dx is equal to 0. Okay, now here if you put the upper and lower limit here, you see, if you put here +1, if you put here +1 instead of x square, then 1 minus 1 cancel. Similarly, if you put here -1, then after squaring, that's going to be again +1 and +1, and this is minus, so that's going to be cancel again, right? So it doesn't matter what you put here, +1 or -1 in x square, you're going to always get this term -1 square, or here +1 square, it's going to be always 1. So 1 minus 1, 0. So we can say that after putting the upper and lower limit, this part will be 0, because 0 into anything is 0. So that's why we have got 0 here. Then plus we have got this part. Let me write this. Okay, so this is what we have got. Now you see, on the right hand side we have 0. Let me put here 0. So here you see, so from here you see, we can write this part is constant, so we can write this way. Therefore it implies minus 1 yz dx minus 1 to plus 1 integration of yz dx is equal to 0. Now you see, let me copy this last part and let me go to a new slide. So here is the last part, right? Now let me go back to the first slide. Here you see, so here I have written that this is solution of this equation. What does it mean? That means y is equal to here Pn of x, right? Similarly, Pm of x is the solution of this equation. That means what does it mean? Z is equal to Pm of x, right? So here we can write that this is equal to y, and here we can write this Pm of x, that's equal to z. Here we can write this is equal to z. So let me go back to the last slide. Okay, what we have got here, you see. So here you see, this y and z can be replaced by y is equal to Pn of x and z is equal to Pm of x. Okay, hope you have understood this. And let me mention one more thing. Let me go back to the second slide. Here you see, so in this property it is already mentioned that m is not equal to n, because here you see, if m is equal to n, then this part will be 0, and 0 into anything is 0. So that's why this part cannot be equal, m cannot be equal to n here in this case. Otherwise we will not get this part on this right hand side, so it will be meaningless, right? So what we have to do now, therefore we're going to put minus 1 integration minus 1 to plus 1 integration of what? Y means Pn of x into z means Pm of x, that is equal to 0 we have got here. So this is what we need to prove. Okay, for m is not equal to n, right? Hope you have understood this. So thank you for watching. See you in the next video. Bye bye.